This question says the following figure shows a particle level view of a sealed container partially filled with a solution of two miscible liquids, X the blue spheres and Y the red spheres. So option A, pure Y has a higher vapor pressure than pure X. So when talking about vapor pressure, it's important to understand that vapor pressure in a container comes from these gas molecules bumping into the side of the container, and that exerts a force on the side of the container, and that's what that pressure is. Also, these molecules in the gas phase are constantly also bumping into the liquid and condensing back into the liquid. And then particles in the liquid phase are also constantly escaping into the gas phase. And what vapor pressure is when those two processes have reached an equilibrium, meaning that liquid is escaping into the gas phase at the same rate that gas particles are condensing back into the liquid phase. So you'll notice that there are three gas particles of red and also three of blue. But there's much more blue in the liquid than the red. So we can conclude by this that if the liquid were only red, that there would be much more red gas particles because those seem to be escaping into the gas phase at a higher rate than the blue. And that just means that pure red is going to have a higher vapor pressure. So we know that this option A is correct. Option B, Y is the solvent in this solution. So typically a solute is what you add to a solvent. So a solute is going to be what is in a solution in smaller quantity than the solvent most of the time. So in this case, that is the red. So red is going to be the solute, meaning option B is not correct. Option C, the presence of Y in the solution lowers the vapor pressure of X. So this has to do with intermolecular forces. When you add a solute to a solution, then the solvent and the solute are going to bind together, and the forces that bind them together are stronger than the intermolecular forces between the molecules of the pure solvent in itself. So in other words, if you have a glass of water, the water molecules are bound together with intermolecular forces. If you add sodium chloride to the water, then the sodium and the chloride ions are going to bind to the water molecules. And the bonds between the sodium and chloride ions and the water are stronger than just the bonds between water and itself. So because the strength of the intermolecular forces increases when you add a solute, it means that more energy has to go in to those molecules in order for them to escape into the gas phase, meaning that the vapor pressure will decrease. So option C is correct. Option D, if Y were not present, there would be more X particles in the gas above the liquid solution. This is really the same question as option C, and so it is also true.